Imagine a region of space smaller than a single proton. Inside this tiny speck lies all the matter and energy that will ever exist. Every star, every galaxy, and every atom in your body is compressed into this single point. Then, the clock starts. In just 1 second, this speck expands and transforms into a universe light years across. Welcome to the most important second in history. I am your host, and this is the complete history of the universe. Today, we are dissecting Episode 1, the first second. Most of us have heard of the Big Bang, but few realize how much happened in that opening instant. This was not an explosion in space, but an explosion of space itself. We begin at time zero, or as close to it as physics allows it. This is the Planck Epoch. For the first fraction of a second, the universe is so hot and dense that our current understanding of physics breaks down completely. We cannot say for certain what happened here because gravity was likely merged with the other forces of nature. It is a realm of pure energy and mathematical silence. At 10 to the power of -43 seconds, gravity separates from the other fundamental forces. This marks the first tick of the cosmic clock that we can theoretically describe. The universe is now in the grand unification epoch. The strong nuclear force, the weak nuclear force, and electromagnetism are all fused into one single superforce. The temperature is unimaginable, roughly 10 to the power of 32 Kelvin, but this unity does not last. Around 10 to the power of -36 seconds, the strong nuclear force breaks away. This separation triggers a violent event known as cosmic inflation. Suddenly, the universe expands faster than the speed of light. It grows from the size of a subatomic particle to the size of a grapefruit in less than a billionth of a trillionth of a second. This expansion irons out any wrinkles in space, making the universe smooth and uniform. Inflation stops as abruptly as it began. The energy driving this expansion dumps itself into the vacuum, creating a hot soup of particles. This process is called reheating. We have now reached the Electroweak Epoch. The universe is a buzzing plasma of quarks, gluons, and exotic particles like the Higgs boson. However, particles still have no mass, so they zip around at the speed of light. Then, at 10 to the power of -12 seconds, the universe cools just enough for the Higgs field to activate. Particles interact with this field and suddenly gain mass. This is a pivotal moment because without mass, atoms could never form. At this same moment, the weak nuclear force separates from electromagnetism. Now, the four fundamental forces of nature are finally distinct, just as they are today. We enter the quark epoch. The universe is filled with a dense, hot plasma of quarks and gluons. It is still too hot for these quarks to bond together to form protons or neutrons. During this time, matter and antimatter are annihilating each other in a great cosmic battle. Fortunately for us, for every billion particles of antimatter, there are 1,000,000,001 particles of matter. This tiny imbalance is the only reason our universe is not just empty radiation today. As the clock ticks toward 1 millionth of a second, the universe cools to about 10 trillion degrees. We now cross into the Hadron Epoch. The strong nuclear force finally captures the quarks, binding them together. Triplets of quarks snap together to form the first protons and neutrons. This process is called confinement. The universe is now populated by the building blocks of atomic nuclei. But it is still a chaotic place. Neutrinos, ghostly particles that barely interact with anything, are trapped in this dense plasma. They constantly collide with protons and neutrons, keeping the ratio of these particles in flux. But as we approach the 1 second mark, the density drops. Suddenly, the neutrinos break free. They stream out into the void, forming a cosmic neutrino background that still fills the universe today. The decoupling of neutrinos marks the end of the 1 second. The universe is now a vast cooling fog of protons, neutrons, electrons, and photons. It is still too hot for actual atoms to hold together. That stability will require a few more minutes of cooling. But the blueprint is complete. The forces are set, the particles are made, and gravity is ready to start building structure. In the span of a single heartbeat, the cosmos went from a mathematical singularity to a physical reality. Next time, we will watch as this hot soup cooks into the very first chemical elements. Join us for Episode 2.